You stand in your city, concrete streets, steel buildings, power lines running overhead, everything built to withstand wind, earthquake, fire. But there's one force that laughs at every defense we've ever built: water. Not the gentle rain that fills your gutters, not the stream that runs through the park. The water that destroys cities comes fast, comes high, comes from places you never expected. Mountains collapse into reservoirs and send walls of liquid death downstream. Glaciers crack and unleash floods that rival the Amazon. Storm surges push entire oceans onto land, and the ground itself opens up, releasing water that's been trapped for centuries. Which type erases your home? Which one gives you 30 minutes to run? Which one gives you 30 seconds? Glacier leap. The word itself tells you what's coming. On August 13th, 2025, residents near Mendenhall Glacier in Juneau, Alaska, watched water levels hit record highs at Mendenhall Lake. The surge came from Suicide Basin, a side glacier that had been filling with meltwater all summer. When the ice dam broke, millions of gallons punched through tunnels in the glacier and roared downstream. Emergency barriers held, this time. 1 year earlier, in 2024, the same basin flooded neighborhoods. 2 years before that, in 2023, same story. The glacier is melting faster now, the basin fills quicker, the ice dams weaken sooner in the season. This isn't random, this is the new pattern. According to NOAA research published in August 2025, this type of event reflects a growing global risk as mountain glaciers retreat worldwide. The Mendenhall floods are textbook Jokolops: ice-dammed water, sudden release, catastrophic downstream surge. But Alaska's floods are warnings, not the main event. The real monster Jokolops happen in Iceland. Grímsvötn volcano sits under Vatnajökull, Europe's largest glacier. When the volcano heats up, it melts ice from below, water pools in a subglacial lake, pressure builds, then the ice seal breaks. In 1996, the Galp eruption sent meltwater south into Grímsvötn. The resulting Jökulhlaup peaked at 500,000 cubic meters per second. That's 18 million cubic feet every single second. The largest Grímsvötn glacial flood ever recorded, according to research published on Wikipedia in July 2025. The flood lasted several days. By comparison, the Amazon River averages 200,000 cubic meters per second. The Grímsvötn surge was more than twice the Amazon. For days. From a glacier. Another Icelandic volcano, Eyjafjallajökull, the one that shut down European air travel in 2010, generated Jökullaups that cascaded down the northern and southern flanks. Peak discharge hit 2,000 to 3,000 cubic meters per second. Not as massive as Grímsvötn, but the flood reached highways and cut off Iceland's ring road within hours of the eruption starting. Also, comment from which city you're hearing this from. Also, this script is researched and factual, using sources from the Icelandic Meteorological Office published continuously through 2025, and peer-reviewed studies in the journal Boreas, published in August 2025, detailing early Holocene Jökulhlaup chronology in Central. Iceland using chlorine-36 cosmogenic nuclide exposure dating. This is cutting-edge glacial flood science. Now back to the information. No slow rise, no gradual warning. The hydrograph just shoots vertical. Temperature also matters. When Mýrdalsjökull, another Icelandic glacier, released a Jökulhlaup in late July 2024, geothermal calderas beneath the ice triggered the event. Electrical conductivity in the Lera, Sidrai, and Skalm rivers started climbing on July 7, 2025, signaling another developing flood. Birgur Einarsson, head of hydrological research at the Icelandic Meteorological Office, said in a statement published July 9, 2025, that the causes of the previous year's large flood are still not fully understood, but geothermal boiling triggered by pressure release from a small glacier slide could be replicating the process. Eyjólfur Magnusson from the University of Iceland's Institute of Earth Sciences conducted radar measurements since May 2025, showing substantial water accumulation at the base of Mýrdalsjökull. The glacier is sitting on a loaded gun. The scale of historic Jökullaups dwarfs modern engineering. When the Laurentide ice sheet receded from the Adirondack Mountains in the St. Lawrence lowlands, between 21,000 and 13,000 years ago, glacial Lake Iroquois drained to the Atlantic in 3 catastrophic Hudson Valley releases. Each time the ice dam failed and re-established itself. The evidence is carved into bedrock. The channeled scablands in Washington state tell an even bigger story. During the last ice age, glacial Lake Missoula in Montana held more water than Lakes Erie and Ontario combined. When the ice dam broke, 600 cubic miles of water exploded across eastern Washington in less than 48 hours. The flood moved at 60 miles per hour, carrying boulders the size of houses, stripping soil down to basalt, carving gorges 300 feet deep. The discharge peaked at 10 times the combined flow of every river on Earth. Today, geologists use those scablands to understand what catastrophic flooding can do. The rock doesn't lie. A study published in Nature Communications in February 2023 analyzed 1569 ice dam failures across 6 major mountain regions between 1900 and 2021. The research found that extreme peak flows and volumes have declined by about an order of magnitude over this period in 5 of the 6 regions. Sounds good, right? Not quite. The same study found that ice dam floods worldwide today originate at higher elevations and happen about 6 weeks earlier in the year than in 1900. The glaciers are retreating upslope. The water releases sooner in the season when downstream communities are less prepared. The floods are smaller on average, but happening in new places at unexpected times. In June 2025, research published in Natural Hazards and Earth System Sciences examined Fjalsjökull, an outlet glacier of Vatnajökull in southeast Iceland. The proglacial lake Fjalsárlón significantly expanded from 1945 to 2021. If recent glacier terminus retreat rates continue, Fjalsárlón is estimated to reach its maximum extent within the next 1 to 2 centuries, more than doubling in surface area and tripling in volume. The lake will occupy 2 overdeepened basins with a maximum depth of approximately 210 meters. That's a future Jökulhlaup waiting to happen. When that lake drains, everything downstream is in the path. On July 26, 2005, Mumbai measured 944 millimeters of rain in 24 hours. That's 37 inches in one day. The previous Mumbai record was 575 millimeters in 1974. This wasn't close to the old record. This obliterated it. The cloudburst hit around 2 in the afternoon. By 2:30, local trains stopped moving because water covered the tracks. Roads flooded within minutes. Dharavi and Bandra-Kurla complex, low-lying pockets of the city, submerged completely. The drainage system, built in the early 20th century, was designed to handle 25 millimeters per hour. The cloudburst dumped rain at rates exceeding 39 millimeters per hour for sustained periods. The math doesn't work. You can't drain 994 millimeters through pipes built for 25. At least 419 people died in the Mumbai municipal area from the flash floods and landslides, according to a 2016 research paper published in ResearchGate. Another 216 died from flood-related illnesses in the following days. Chhatrapati Shivaji Maharaj International Airport and Juhu Aerodrome shut down for more than 30 hours. Over 700 flights canceled or delayed. The stock exchanges functioned only partially. ATM networks across the nation stopped working because the central systems were in Mumbai. The city effectively paralyzed for 48 hours. A series of cloudbursts hit the northern Indian state, causing flash floods and landslides. The worst affected area was Kedarnath, home to an 8th century temple dedicated to Lord Shiva. The sudden rapid melting of ice and snow on Kedarnath Mountain, 6 kilometers from the temple, flooded the Korabari Lake upstream. Then the lake breached. The water hit Kedarnath with millions of tons of mud, boulders, and debris. The temple itself wasn't damaged, but everything around it was obliterated. The market town of Rambada disappeared. Gaurikund obliterated. Sonprayag suffered heavy casualties and massive structural damage. Over 70,000 people stranded in various regions because roads were destroyed or blocked. According to the National Disaster Response Force, the official death toll exceeded 6,000 people, making it India's worst natural disaster since the 2004 tsunami. But many bodies were never recovered. The actual number could be much higher. A study published in the Journal of Earth Science and Climatic Change noted that the extent of damage was amplified because the cloudburst hit during peak pilgrimage season. Hundreds of thousands of devotees were in the region. Emergency responders found it almost impossible to reach remote areas. The Indo-Tibetan Border Police deployed 2,000 personnel and rescued 33,009 pilgrims in 15 days using mountaineering skills and improvisation. On June 25th, one of 3 Indian Air Force MiL-Me-17 rescue helicopters crashed near Gaurikund, killing all 20 people on board, including 5 Air Force officers, 9 NDRF members, and 6 ITBP personnel. By definition, a cloudburst dumps more than 10 centimeters of rain in less than an hour over an area of approximately 10 square kilometers. The India Meteorological Department tracks these events, but predicting exactly where they'll occur remains nearly impossible. The resolution of satellite precipitation data is usually worse than the area of cloudbursts, so they go undetected until they're already happening. In the Himalayas, orographic lifting creates the perfect conditions. Moist monsoon clouds from the Bay of Bengal or Arabian Sea move north, across the plains, hit the Himalayan slopes, and release rainfall at rates up to 75 millimeters per hour. The steep terrain funnels the water into narrow valleys. Flash floods develop within minutes. On September 28, 1908, the Musi River in Hyderabad rose to 60 feet after a cloudburst. Over 15,000 people died, 50,000 houses destroyed, 3 bridges washed away. The only bridge left standing was Purana Pul, which became the sole link between the two parts of the city. In the Kolsawadi and Ghansi Bazaar areas of Afzal Gunj, 80,000 houses were washed away, leaving a fourth of the population homeless. This event, known locally as Thugiyani Sidambar, remains one of the deadliest cloudbursts in Indian history, according to multiple sources published in 2025. But the violence is absolute. Because the terrain is steep, the runoff velocity increases exponentially as water cascades downhill. A 10-centimeter rainfall on flat ground might cause flooding. The same rainfall on a 40-degree slope becomes a battering ram. In July 2021, Chamoli district in Uttarakhand experienced another cloudburst. Roads destroyed, homes flooded, public infrastructure collapsed. In August 2022, a cloudburst near the Amarnath Shrine during the annual pilgrimage killed at least 15 people. On August 5, 2025, a devastating incident at Darali village in Uttarkashi was initially assumed to be a cloudburst, but India Meteorological Department data later indicated the flood was triggered by a glacial lake outburst. More than 50 structures destroyed. Bridges and houses washed away. As many as 70 people reported missing, according to the Daily Jagran published September 3, 2025. The mechanism changes, but the destruction remains the same. Fast water, steep slopes, no time. One moment the wall holds back a reservoir, the next moment the wall is gone and the reservoir is moving. On August 8, 1975, Typhoon Nina stalled over Henan Province, China. In 3 days, more than 1,500 millimeters of rain fell in parts of the province. That's more than the normal yearly rainfall, delivered in 72 hours. The Benkiao Dam on the Ru River was designed to withstand a 1 in 1,000 year rainfall event of 306 millimeters per day. Typhoon Nina dumped more than 3 times that amount. The dam, built in 1952 with Soviet guidance and labeled an iron dam, was supposed to be unbreakable. On the evening of August 7th, smaller dams below Benkiao started breaking. Dam workers frantically tried to shore them up, trusting the Great Benkiao Dam would hold. Late that night, floodwaters overtopped Benkiao. Just after midnight on August 8th, the dam collapsed. 62 total dams failed in the Huai River system that night, according to Human Rights Watch reports. The Shimantan Dam, the second largest in the flood prevention system, also collapsed. In Dawencheng Commune, all 9,600 citizens died. The commune was wiped from the map. In Suping County, the Wencheng Commune was unevacuated. Half of 36,000 people died. In the evacuated community of Shahadian, just below Benkiao Dam, 827 out of 6,000 died. Evacuation saved most. Lack of evacuation killed half. The official Chinese government death toll is 26,000, all from the flood wave. But 8 members of the Chinese People's Political Consultative Conference, high-ranking government officials, and China's foremost experts in water conservancy produced an estimate of 230,000 deaths. This figure accounts for deaths from the flood itself, from famine, and from epidemics caused by contaminated water. Unofficial estimates range from 85,600 to 240,000. For comparison, the atomic bomb dropped on Hiroshima killed an estimated 140,000 people by the end of 1945. The Benkiao Dam failure may have killed more. The dam was built to handle 306 millimeters of daily rainfall, but hydrological data was lacking. The engineers had no resources or equipment to model extreme flood events. Political climate also played a role. During the Cultural Revolution, experts were afraid to express concerns about the dam's adequacy, lest they be condemned for questioning Chairman Mao. After the disaster, Xinhua journalist Zhang Guangyu visited the area and interviewed experts who privately told him that degradation and damage to the ecosystem due to Mao's Great Leap Forward were major causes of the collapse. Communication failures made everything worse. Typhoon Nina disrupted telephone lines to Benkiao Dam. Downstream areas received no messages. Officials assumed the dam had contained the floods. The dam control room was located within the inundation zone of the reservoir, so when the flood hit, the building became uninhabitable and all communication ceased. By August 9th, even after the rain stopped, the floods continued. The dikes on the Quan River collapsed on the evening of August 9th. Lincoln County in Fuyang, Anhui was inundated. 102 kilometers of the Jingguang Railway, a major artery from Beijing to Guangzhou, was cut for 48 days. Over 10 million people were displaced. 3 million acres of farmland destroyed. Nearly 6 million buildings destroyed, leaving 11 million people homeless. According to an article published in Man-Made Catastrophes in April 2025, the disaster was kept hidden for decades. Even many who lived through it didn't realize they'd experienced anything more than a particularly bad flood. Information about Banqiao only reached the public in the 1990s when the book The Great Floods in China's History, prefaced by former Minister of Water Resources Qian Zhengying, revealed details. Official documents weren't declassified until 2005. Italy has its own dam disaster story, but the dam didn't fail. The dam survived. Everything else died. On October 9th, 1963, at 10:39 in the evening, 260 million cubic meters of rock broke off from Monte Toc on the border between Veneto and Friuli Venezia Giulia and fell into the reservoir of the Vajont Dam. The landslide moved at 68 miles per hour. When it hit the water, it displaced 50 million cubic meters, creating a mega tsunami 250 meters high. The wave shot up and over the dam crest. The dam itself, designed in the 1920s and completed in the late 1950s, stood 850 feet tall. One of the tallest dams in the world. The concrete held, but the wave didn't care. 250 meters of water crashed over the top and roared down the Piave Valley. The town of Longarone, almost directly below the dam, was nearly completely destroyed. Around 80% of its inhabitants drowned. The nearby villages of Fay, Pirago, Rivalta, and Villanova also suffered casualties and significant damage. About 2,000 people died. Many bodies were never recovered. The south side of Monte Toc had a history of landslides. During the dam's construction, which began in 1957, numerous fractures and shifts appeared in the road to the dam. Several geologists and engineers issued strong warnings about the risks of filling the reservoir too quickly and the potential for a catastrophic landslide. SAID, the company building the dam, dismissed the warnings. In 1960, shortly after the first filling began, small landslides occurred. The south coast slid about 3.5 centimeters per day. A 2-kilometer-long crack formed. SAID conducted scale model tests at 1 to 200 scale and concluded that even if a landslide occurred, the resulting wave would cause negligible damage downstream. The models were wrong. By early October 1963, the collapse looked unavoidable. In one day, the mountain moved almost 1 meter. SAID tried to lower the reservoir level, but it was too late. On October 9th, engineers witnessed trees falling and rocks rolling down. Based on their simulations, they believed only a small wave would form. Then at 10:39, the mountain fell. The displacement wave had a smooth, hyperconcentrated front, followed by turbulent flow. The peak on the right of the dam is officially named Monte Toc, the walking mountain, because of its propensity for landslides. Locals knew, engineers ignored. After the disaster, the Italian government and SAID initially argued the landslide was an unforeseeable act of God. It took years before the tragedy was publicly recognized for what it was, a classic failure of engineers and geologists to understand the problem they were trying to solve, according to UNESCO's description in 2008. Several employees were eventually sentenced for negligence and manslaughter. Mario Pancini, the engineer of the dam project, was summoned to court. He killed himself before his scheduled appearance. Today, the Vajont Dam still stands, completely empty, a monument to hubris. Since 2002, the public has been allowed to visit. Guides offer tours and the chance to walk along the top of the dam. Below, the basin is almost entirely drained, filled with rocks and earth that fell from Monte Toc that night. A visitor center in Erto, one of the mountain villages damaged in the disaster, explains what happened. In October 2025, Italian Prime Minister Giorgia Meloni described it as a disaster that could and should have been prevented. After 61 years, Italy still carries that scar. Storm surges don't come from the sky. They come from the ocean, pushed by wind, amplified by pressure, funneled by coastline geometry. On August 29, 2005, Hurricane Katrina made landfall near Buras Triumph, Louisiana, as a Category 3 storm with sustained winds of 120 miles per hour. The storm surge that followed was the real killer. In Mississippi, the surge exceeded 26 feet along the coast from Gulfport to Biloxi. Some measurements put it at 28 feet above normal tide levels. In Alabama, the storm surge reached 11.45 feet at Mobile State Docks, nearly matching the record of 11.6 feet set in 1916. But New Orleans got the worst of it. The city sits mostly below sea level. Levees and flood walls were designed to protect against storm surges up to 23 feet. The forecast called for 28 feet. On August 28th, Mayor Ray Nagin ordered the first ever mandatory evacuation of the city. About 80% of the 1.3 million residents in the greater New Orleans metropolitan area evacuated, but an estimated 100,000 to 150,000 people remained. The 17th Street Canal failed. The Industrial Canal breached on both the northeast and southeast sides. The London Avenue Canal failed. Some floodwalls collapsed well below design thresholds. Others collapsed after brief overtopping caused scouring and erosion of earthen levee walls. By the afternoon of August 29th, some 20% of New Orleans was underwater. By August 30th, 80% was submerged. A June 2007 report by the American Society of Civil Engineers indicated that 2/3 of the flooding was caused by multiple failures of the city's flood walls and called it the worst engineering catastrophe in U.S. history. The death toll from Katrina remains uncertain. According to the National Hurricane Center, 1,836 fatalities can be attributed to the storm. 1 in Kentucky, 2 each in Alabama, Georgia, and Ohio, 14 in Florida, 238 in Mississippi, and 1,577 in Louisiana. However, 135 people remain categorized as missing in Louisiana. The storm caused an estimated $125 billion in damage, making it the costliest natural disaster in United States history. Many people who didn't evacuate were unable to due to medical reasons or had limited access to transportation. About 10,000 went to the Louisiana Superdome, which sheltered approximately 26,000 people during the storm. Those who stayed in their homes often became trapped in attics as water levels rose. Mayor Nagin had urged residents to store hatchets and sledgehammers in their attics so they could chop their way onto roofs if needed. Many did exactly that. Footage from the days after Katrina shows rooftops across the city dotted with survivors. Levee design also played a role. Construction of the modern levee system began in 1965 after Hurricane Betsy flooded much of the city. The Army Corps of Engineers built a complex system of 350 miles of levees. But a 2006 Corps report concluded that insufficient funding, inadequate information, and poor construction left the flood system vulnerable. Even before Katrina made landfall, the incoming storm surge had started overwhelming levees and spilling into residential areas. More than 50 levees eventually failed. A recent study found that decades after Katrina, the city's flood walls are continuing to sink nearly 2 inches each year. The ground is subsiding, the walls are dropping, the next storm surge is coming. The Joint Typhoon Warning Center assigned 1-minute sustained winds at 170 knots, which equals 196 miles per hour. That made Haiyan possibly the most powerful tropical cyclone to ever make landfall anywhere. The storm surge that followed was even more terrifying. In Tacloban, a city of around 240,000 inhabitants, the surge reached 5 to 7.5 meters high. Some eyewitness reports from downtown Tacloban placed the surge as high as 8.5 to 9.1 meters. That's 27 to 30 feet. Tacloban sits at the head of San Pedro Bay in a particularly vulnerable position. Much of the city sits only 5 meters above sea level. The bay's funnel shape amplified the surge. Fortunately, the peak surge occurred during relatively low tide. If it had occurred at high tide, the water level would have been 0.5 meters higher. According to research published in the Bulletin of the American Meteorological Society in January 2016, the storm surge in Tacloban was comparable to an unnamed typhoon that struck the same area in October 1897, which produced a 4.5 meter surge. The storm affected more than 16 million people across the Philippines and left 4 million homeless. In its most recent update from April 2014, the Philippine government confirmed 6,300 dead and more than 1,000 still missing. Samar and Leyte Islands suffered the most devastating damage. Nearly all structures in the township of Guiuan suffered at least partial damage, and many were completely flattened. For several days following Haiyan's first landfall, the damage situation in Guiuan remained unclear due to lack of communication. Philippine Air Force staff arrived on November 10th to finally assess the damage. In Tacloban, widespread devastation from the storm surge destroyed buildings, knocked over trees, and piled up cars, especially in the low-lying areas on the eastern side of the city. Some areas were completely washed away. Flooding extended 1 kilometer inland on the east coast of the province. A January 2014 mortality assessment conducted by the Department of Health in Tacloban identified 2,321 deaths distributed across the city's 138 villages and subvillages. The study found that the greatest risk factor for mortality was not evacuating before the storm hit, with an odds ratio of 10.0. Exiting houses during the storm increased risk by 3.6. 95% of cases didn't evacuate because they didn't expect the magnitude of the storm. 88% of cases didn't understand the message about storm surge. The term itself wasn't widely understood. If you value documented storm mechanics and disaster science like this, subscribe. It's the best way to support our work. Also, comment from which city you're hearing this from. Also, this script is researched and factual, using sources from No AA Climate, published in July 2014, analyzing record-breaking Super Typhoon Haiyan, and peer-reviewed studies in geophysical research letters, examining local amplification of storm surge by the specific bathymetry of Leyte Gulf and the Philippines Trench, published in March 2014, were using cutting-edge tropical cyclone research. Now back to the information. The storm surge displaced air with a force supposedly more powerful than the atomic bomb dropped on Hiroshima. Victims were found with their clothes blown off, skin damaged, internal organs ravaged by the force of the blast. A cargo ship, the MV Eva Jocelyn, was forced inland during the typhoon and now sits as a memorial park. The airport was struck by a 6-meter-high storm surge and rendered inoperable. It took 3 days before flights could land with relief supplies, and even then, only small planes could land. This led to lack of basic supplies like food and water. Long lines formed. Widespread looting took place in the days following Haiyan's passage. Relief trucks were attacked. 2 of the city's malls and numerous grocery stores were looted. A fuel depot was guarded by armed police. Security checkpoints were set up across Tacloban, and a curfew was imposed. By November 10th, the death toll exceeded 4,000. Some 4 million people were displaced. The Disasters Emergency Committee noted that over 14 million people were affected across 46 provinces. 4 million people saw their homes severely damaged or destroyed, with 550,000 houses completely destroyed and an additional 580,000 severely damaged. Before 2013, existing mangroves had been cut down to make way for fish farming. Mangroves reduce in slow storm surges. Without them, the full force of the surge hit the city directly. In the aftermath, Tacloban communities have been restoring mangroves, working with civil society organizations and local government to integrate nature-based solutions. 10 years on, according to a report by the United Nations Office for Disaster Risk Reduction published in November 2023, survivors are still rebuilding their lives. But wide-ranging resilience measures mean that previously at-risk communities are now better protected. When Typhoon Rai, locally named Typhoon Odette, struck with wind speeds up to 270 kilometers per hour in December 2021, the damages were significant, but the country was able to respond preemptively, evacuating more than 400,000 people from the E. Storms path. Early warning systems like PhilAware, developed in partnership with the University of Hawaii's Pacific Disaster Center, now provide the information needed for early warning and rapid response. On December 26, 2004 at 7:58 in the morning local time, a magnitude 9.1 earthquake struck off the western coast of northern Sumatra, Indonesia. The epicenter was 30 kilometers under the seabed and approximately 250 kilometers south-southwest of Banda Aceh. The earthquake ruptured roughly 800 miles of fault line, similar in length to California. It released energy equivalent to 23,000 Hiroshima-type atomic bombs. The tsunami generated by this earthquake killed an estimated 228,000 people across 14 countries, making it the deadliest tsunami in history. Indonesia's Aceh province suffered the greatest mortality. Around 130,000 people died in Aceh alone. 38,786 were listed as missing. 504,518 were displaced. Within 15 to 20 minutes of the earthquake, the first giant waves reached Banda Aceh, a city of about 300,000 people. Few residents realized that the earthquake they'd felt could cause a tsunami. There was little time to flee to higher ground. The greatest run-up height of the tsunami was measured at a hill between Lokanga and Lupung on the western coast near Banda Aceh, and reached 51 meters. That's 167 feet. In Banda Aceh itself, the inundation extended 3 to 4 kilometers inland. Within 2 to 3 kilometers of the shoreline, houses, except for strongly built reinforced concrete ones, were swept away or destroyed. The area toward the sea was wiped clean of nearly every structure. In the seaside section of Uli Loy, flow depths exceeded 9 meters. Footage showed evidence of backflowing of the Aceh River, carrying debris and people from destroyed villages at the coast, and transporting them up to 40 kilometers inland. Around 60,000 people were confirmed killed in Banda Aceh alone. The town of Lok Nga, where tsunami run-up height reached over 30 meters, had a pre-tsunami population of 7,000. After the tsunami, between 200 and 400 survived. Lupung, a town with a population of 10,000 in Aceh Besar district, was obliterated. Estimated survivors ranged between 200 and 700. The eastern shores of Sri Lanka faced the epicenter and were hardest hit. Civilian casualties there were second only to Indonesia, with approximately 35,000 killed. Thailand's Khao Lak experienced the largest tsunami run-up height outside of Sumatra. The highest recorded run-up was measured at 19.6 meters at Banthong Dap. The largest death toll in Thailand occurred at Khao Lak, with about 5,000 people killed. Video footage from Koh Lanta showed a wall of water-swamping beaches, lifting up yachts and flooding shorelines. The tsunami reached Malaysia, mainly affecting northern states like Kedah, Perak, and Penang. Peninsular Malaysia was partially shielded by Sumatra. The tsunami even reached Somalia in Africa, 7 hours after the earthquake. In Hafun, 19 people died and 160 were presumed missing out of 5,000 inhabitants. This was the highest number of casualties in a single African town and the largest tsunami death toll in a single town west of the Indian subcontinent. In 2004, there was no tsunami warning system for the Indian Ocean. Natural warnings included the earthquake itself, withdrawal of the sea, and unusually large initial waves. Unfortunately, these weren't widely understood as warnings. Many witnesses rushed to the exposed ocean floor to collect stranded fish. Some continued with their daily activities. In small island communities, where stories about tsunamis had been passed down through generations, thousands of lives were saved. On Semilu Island, west of Aceh, an oral tradition preserved from a smaller tsunami in 1907 caused residents to run to higher ground when they felt the earthquake. Only 5 of 70,000 villagers were killed, all in the earthquake itself, although 90% of buildings along the coast were destroyed by the tsunami, which reached up to 5 meters high. Knowledge saved lives, ignorance killed. According to research published by Geoscience Australia in June 2023, if there had been a tsunami warning system for the Indian Ocean in 2004, better communications networks, and greater public understanding of tsunamis and how to respond, tens of thousands of lives likely would have been saved. Long-term environmental damage was severe. Villages, tourist resorts, farmland, and fishing grounds were demolished or inundated with debris, bodies, and plant-killing saltwater. Together, the earthquake and tsunami changed the landscape of many Indian Ocean coastal communities. Coastal erosion and subsidence caused some shorelines to disappear into the ocean. In some areas, uplift forced coral reefs to rise above the surface. According to World Vision reports published in July 2025, relief efforts across 5 countries, India, Indonesia, Myanmar, Sri Lanka, and Thailand, involved one of the most extensive humanitarian operations in history. A total of $6.9 billion was committed to Aceh's recovery and reconstruction by the Indonesian government and about 900 bilateral and multilateral donors and non-governmental organizations. The Indian Ocean Tsunami Warning and Mitigation System was established in 2005 under the Intergovernmental Oceanographic Commission of UNESCO. The system provides comprehensive risk assessment, early warning capabilities, and community awareness programs. The Tsunami Ready Recognition Program, launched internationally in 2008, promotes community preparedness through education and drills. Sea level monitoring stations now dot coastlines around the Indian Ocean. Earthquake detection networks trigger automatic alerts. Coastal communities conduct regular evacuation drills. But even with the best warning systems, local tsunamis, generated by nearby earthquakes, still pose extreme danger. Japan's experience with the 2011 Tohoku earthquake and tsunami, which killed over 15,000 people despite sophisticated warning systems and tsunami-aware coastal communities, proves that local tsunamis can still inflict massive casualties. The wave simply arrives too fast. In the case of Banda Aceh, 15 to 20 minutes isn't enough time to evacuate a city of 300,000. The only defense is elevation. Run uphill, run inland, run fast. In July 2025, researchers published a study in the journal Water Resources Management analyzing glacial lake outburst flood hazard and risk assessment in the Kashmir Himalaya. The paper emphasized that climate change is accelerating glacier retreat and mass loss in the western Himalayas, intensifying the risk of GLOFs. With over 5,000 glacial lakes, more than 200 classified as potentially dangerous, the Himalayan region faces mounting hazards due to the expansion and instability of these lakes. Notable GLOF events include Kedarnath in 2013, Gya in 2014, and South Lonak in 2023. Jammu and Kashmir and Ladakh have seen a sharp increase in the number and size of glacial lakes over the past decade. On February 7, 2021, part of Nanda Devi Glacier broke away in Uttarakhand. The event caused a huge flash flood. At least 200 laborers were dead or missing at the Tapovan Vishnugad and Rishiganga Hydel projects. The incident was initially attributed to a glacier burst, but later analysis suggested a rock and ice avalanche triggered the flood. Cloud bursts come from mountains, localized and intense, dropping a year's rainfall in hours onto slopes too steep to absorb it. Dam failures come from engineering and hubris, releasing reservoirs in minutes when walls that should hold for centuries collapse. Storm surges come from tropical cyclones, wind-driven walls of ocean pushed onto land by low pressure and coastline geometry. Tsunamis come from earthquakes, energy transferred from tectonic plates through thousands of miles of ocean to arrive as waves taller than buildings. Each type destroys differently. Each type kills differently. Each type leaves evidence in sediment, in records, in the landscape. In 2025, a comprehensive analysis was published tracking 1569 ice dam failures across 6 regions. The patterns are clear. Floods are happening earlier in the season. Glacial floods originate at higher elevations. Storm surges are amplified by rising sea levels. Coastal development removes natural barriers like mangroves. Cities expand into floodplains. Populations grow in high-risk zones. The mechanisms haven't changed. The exposure has increased. More than 50 structures destroyed. Bridges washed away. As many as 70 people missing. The flood mechanism changes, but the water doesn't care. In July 2025, a glacial outburst flood developed in Iceland's Lera, Sidrey, and Skalm rivers, following rising water levels and electrical conductivity measured since July 7th. Conditions intensified through July 9th. Birgir Einarsson at the Icelandic Met Office said the causes are still not fully understood, but geothermal activity beneath Mýrdalsjökull is creating substantial water accumulation. The flood is building. The ice dam will break. The pattern repeats. A 2023 study published in Nature Communications examined global ice dam failures from 1900 to 2021. Extreme peak flows have declined, but median discharges remained unchanged. The floods are smaller on average, but happening in new locations at unexpected times with less warning. A 2025 paper in Natural Hazards and Earth System Sciences examined proglacial lake development at Fjalsjökull in Iceland. If retreat rates continue, the lake will more than double in surface area and triple in volume within 1 to 2 centuries, reaching maximum depths of 210 meters. That's a loaded weapon. When it discharges, everything downstream is in the path. A 2014 study in No AA Climate analyzed Typhoon Haiyan and found that sea level around central Philippines has risen 200 millimeters since 1970. Higher sea levels contribute to increased coastal flooding during storm surge events. The baseline is shifting. A 2005 study in the American Society of Civil Engineers report on Hurricane Katrina determined that 2/3 of New Orleans flooding was caused by floodwall failures, not the storm itself. The engineering failed. A 2025 analysis of dam safety by the Association of State Dam Safety Officials noted that China has 87,000 reservoirs, most built in the 1950s through 70s, using low construction standards. Most are in serious disrepair, posing challenges for 130 million people downstream. The infrastructure is aging. The risk is compounding. The new reservoir is 34% larger than the original. The memorial created by Henan Water Resources Department acknowledges the human toll, but provides limited statistics. The Vajont Dam still stands, empty, a monument. Since 2002, tours are allowed. You can walk the crest. Below, the basin remains filled with 260 million cubic meters of rock from Monte Tauk. The dam survived. The valley died. New Orleans rebuilt levees after Katrina, but a recent study found the flood walls are sinking 2 inches per year. The ground subsides. The structures drop. The next surge is coming. Tacloban rebuilt after Haiyan. Mangroves restored. Early warning systems installed. When Typhoon Rai hit in 2021, 400,000 people evacuated. Damage was significant, but casualties were minimal compared to Haiyan. Preparation works. Banda Aceh rebuilt. The Aceh Tsunami Museum stands as a memorial. Coastal monitoring stations dot the Indian Ocean. The warning system exists. Local tsunamis still kill because the wave arrives faster than evacuation. The only defense remains elevation. The flood that destroys you depends on where you stand. Glacier country gets jokolops. Mountain regions get cloudbursts and gialofs. River valleys get dam failures. Coastlines get storm surges and tsunamis. But the underlying truth is the same. Water moves downhill. Water fills valleys. Water pushes through barriers. Water doesn't negotiate. Every defense humans build has a threshold. Every threshold can be exceeded. The question isn't if your city can flood. The question is which type arrives first and whether you understand the warning signs 15 minutes before the wall of water hits.